Hello everyone. In this video lesson, you're going to learn how to find all real roots of polynomials. Okay, so we're going to use a calculator to help us find the solutions by step number 1, typing into y equals, and then looking at the graph or graphing it. And then step 2, find the roots or x-intercepts by what you see in the calculator. And then step 3, we're going to prove with synthetic division whether those solutions from the calculator are the correct ones. Okay, so for the first example, I'm going to go to the calculator and I'm going to reset mine second plus 712, and that should reset every piece of information that was stored there before. Okay, so then I'm going to go to y equals. I'm going to enter this equation, which is x to the third minus 2x squared, and then minus 11x plus 12. And then I'm going to graph this function. Okay, so press graph. And from the calculator, as you can see, it seems like the graph crosses through -3, +1, and 2, 3, and 4. So we're going to check -3, 1, and 4 from the calculator. So now let's go ahead and use synthetic division. So first I'm going to write the solution so I don't have to be looking at the calculator while I'm working on this. Okay, so we have -3, +1, and +4. So question mark. So let's set up synthetic division. So we have from last week before the last exam, first solution is -3. Right, then we have coefficient of x to the third is 1, x to the second is -2, x to the first is -11, and the constant is the number 12. So if this is true, then at the end we should have a 0 remainder in this box. Okay, so I'm going to drop this one here and start multiplying. So this is -3 times 1, that's -3. -2 minus 3, that's -5. -3 times -5, that's +15. -11 plus 15 is 4. -3 times 4 is 12. And as you can see, we have a 0 remainder. So this worked. That means we can move on to the next solution. So now this is when x is 1. So again, drop that 1, multiply 1 times 1 is 1. And then -5 plus 1 is -4. 1 times -4, that's -4. And 4 minus 4, 0. So far this one also checks. Then let's check the last solution based on the calculator, which is when x is 4. So 4 times 1 is 4. And -4 plus 4, 0 remainder. So that means our solutions are correct. Okay, so solutions for this equation or this polynomial is x equals -3, +1, and +4. And that's all for the first example. So moving on to example number 2, I've already entered this in the calculator for the sake of time. So I'm going to graph it. And then from here, we can see that so far we have 2 bounces. It seems like there's a bounce at -3 and another one at +3. So then I'm going to write those solutions for now that I see from the calculator. So the solutions are -3 and +3, and then they seem to be a double. They're both doubles, so we'll check that in a moment. Okay, so double for both, that means we get to use that solution twice. So setting up synthetic division, we have one solution is one of them is -3. And then coefficient of x to the fourth is 1, x to the third, we don't have one, so 0. X to the second is -18. X to the first, we don't have one, so as a placeholder, 0. And then the constant is number 3. So then multiply this using synthetic division. Divide using synthetic division. -3 times 1, that's -3. 0 minus 3, that's -3. -3 times -3, that's +9. -18 plus 9, that's -9. -3 times -9, that's -27, right? And then it seems like I made a mistake here. This should be 81, not 3. So I'm sorry about that. Okay, so then this is -20, +27. Then 0 plus 27 is 27, but -3 times 27 is -81. And as you can see, 0 remainder. So that means we move on to use it one more time because it seems to be a double. So -3 again, -3 times 1, -3, -3 minus 3, that's -6, -3 times -6, that's +18, and -9 plus 18, that's a +9. negative 3 times 9, negative 27. And again, as you can see, so far, this seems to be working. So these two solutions are actual solutions by using synthetic division. We have proved so far. Now we move on to 3. So 3 times 1, 3. Negative 6 plus 3, that's negative 3. 3 times negative 3, that's negative 9. And again, this verifies that this is a solution, at least one of them. So let's move on and do the last one. So then drop the 1, 3 times 1, that's 3, and 3 negative 3 plus 3, that's a 0 remainder. So far, well, we've actually proved that x equals negative 3 is a double solution, and x equals positive 3 is also a double solution. So x equals negative 3 is a double. Okay, and we proved it not just by using the calculator, we actually did synthetic division. And the other is x equals positive 3 is also a double solution. So there we have all 4 solutions for this polynomial as we expected. All right, let's move on to example number 3. So for this one, again, let's graph it. So I have entered the equation in y equals, and then I'm graphing. So I see from the calculator, x seems to be equal to negative 3 is one solution. So for now, we see solutions. One of them is x is negative 3. And then we see a slide, okay, on the graph. So that means that should be a triple solution. So we'll check if x equals 3 is a solution also. So x equals 3, but this one seems to be a triple because of the slide. As the graph crosses the x-axis, it doesn't cut through it, it doesn't bounce, it just slides through that point, okay? So with that said, let's start with negative 3 using synthetic division. So then we have coefficient of x to the fourth is 1, x to the third is negative 6, x to the second we don't have one, x to the first is 54, and the constant is negative 81. So in the end, we show a 0 remainder if this is a solution to this equation. So drop the 1, negative 3 times 1, that's negative 3. This becomes negative 9. This negative 3 times negative 9 is positive 27. Then this is 27. Negative 3 times 27 is negative 81, right? Negative 81. And then let's see. I'm sorry, yeah, 81. So then this will be 54 minus 81, that's negative 27. And negative 3 times negative 27 is positive 81. And as you can see, those cancel. So far, this one works as a single. Let's move on to the next solution. There's 3 of them. So 3, we get to use that 3 times. So 3 times 1, 3. Negative 9 plus 3, that's negative 6. This is negative 18. So then this is 9. 3 times 9 is 27. And 27, negative and positive, cancel out. So far, we know one of them works. Now let's keep going. We have to do it 3 times. Okay, so then 3 again. 3 times 1, 3. This is negative 3. This is negative 9. So this one also works. So 2 of them so far work. One more, because it says that it's a triple based on the graph. So then drop the 1. 3 times 1 is 3. Right, so then this also cancels. So in the end, as you can see, all 4 solutions from the calculator are correct. We just proved them. We just tested them through synthetic division. So in the end, x equals negative 3 is one of them, and the other is x equals positive 3, but this one here is a triple solution, and we have finished this problem. So there's one more, and we'll be done. Okay, so for example number 4, I have entered the information in the calculator, okay, for this equation. So as we can see, x is negative 1, 2, 3, 4, 5, and negative 6. So we have negative 6 and negative 5 as possible solutions, and then we also have 0 passed through the origin, right? So then 0. So now let's use synthetic division. So let's start with negative 6, and then coefficient of x to the third is 1, x to the second is 11, x to the first is 30, and then the constant is 0. So then start multiplying using synthetic division. Okay, so then negative 6 times 1, negative 6, 11 minus 6, that's 5. Negative 6 times 5, that's negative 30. So then we have 30 minus 30, so that's 0 remainder. And I'm not going to do the box yet, but you'll see how redundant this is. Okay, if I continue dividing, which will be the next term, let's see, so if I do this, negative 6 times 0, that's 0. But then this, of course, gives you 0, so you can just forget about this. We can stop here. So then the next one is negative 5. Drop the 1. So then this is negative 5, and this becomes, again, 0. and negative 5 times 0, again, you have a 0 remainder, which is not necessary, so then this is 0 remainder, right? The last one, what if we divide, right? Now, this one is, we don't have to do, but I hope you see it. This is 1, 0 times 1, 0, so as you can see, there is no remainder. So the point is, the solutions worked, okay? So then solutions are x equals negative 6, x equals negative 5, and x equals 0. We saw that from the calculator, and then we proved that those solutions are correct by using synthetic division. That's all for this lesson. I'll see you guys in class. Bye-bye.